Question 1. We've got to write 41,675 to the nearest 1,000. So here we have our units, our tens, our hundreds, and then thousands. And so if we look here at this number here, as it's a 5, a 6, a 7, an 8 or a 9, it would round this number up. So in place of the thousands column we would have 2 instead of 1. So to the nearest 1,000 the answer would be 42,000. Question 2. We have to write the following numbers in order of size. Start with the smallest number. Well, one way I do this is if you write all the decimals underneath each other, keeping the place value, i.e. keeping the columns, the decimal point in the same place, then, and the last one, I would label these A, B, C and D, and then try and imagine that we're looking from the highest place value first and seeing who's in the lead. So I always imagine it like a horse race. That's how I've taught it to very young students. And there's 4 horses in the race and you have to see which one's in the lead. So in terms of the first number, i.e. the units, they're all neck and neck. But then when we come to look at the tenths, here this one's far behind the others because all the others have 2 in the tenths column, whereas this has none. So this must be the lowest, and we can cut that one out. Now let's move to the next column here. Now it's important here that we just put zeros in all the other places. So we're now looking at A, B and D. Now we can see that A is ahead and these both have 0 in this place value. So B and D are far behind A. So we know that A must be the overall winner. But what we've got to do is, so let's get rid of that because that's definitely the one in the lead. So between these two, we're at this place value now, and we can see that D is ahead of B. So 3.2 must be next, and then 3.205. Now we wanted to put these in order of size, and yes, we did have to start with the smallest number, so there we go. Question 3. The bar chart shows the number of hours of sunshine each day last week in Margate and Newquay. On how many days did Newquay have less than 5 hours of sunshine? Well, the 5-hour mark is here. So we can clearly see that we had 1 day, 2 days, 3 days, there's 4 days there where there was less than 5 hours of sunshine. It then says, in total, Margate had more hours of sunshine than Newquay. How many more? Well, let's have a look. So let's do Margate first. And so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. And then in Newquay we would have, I'd count in twos here, so 2, 4, 6, 7, 9, 11, 13, 15, 17, 19, 21, there's 22, 23, 24, 26, 28, 30, 32. So it said Margate had more, yes it did, and there were 7 hours more because we just do 39 take away 32. Question 4. Packs of batteries cost £2.85 each, and Ben has £45 to spend on batteries. We've got to work out that if he buys as many batteries as he can, how much change would he get from £45? So let's see what's the maximum amount of packs that you could buy. So let's do £45. We want to divide that by £2.85. So 45 divided by 2.85, and that will be, well, on the calculator it says 15.789473 and so on. So if we think about it, you can't quite buy 16 packs, okay, because you wouldn't have enough money. So in terms of whole number of packs, you can buy 15 packs. So that's 15 packs maximum. Now we've got to work out how much change he should get from £45. So if we do 15 times 2.85, that will give us in pounds how much 15 packs would cost. So 15 times 2.85 on the calculator, well, that is £42.75. So if we want to work out the change, how much is left, then we'd have £45 take away 42.75. I'm going to use the calculator, and we'd have £2.25p. Question 5. Here is a sequence of patterns made from grey squares and white squares. In the space below, we've got to draw pattern number 4. Well, we know there's going to be 4 grey tiles, because for pattern number 3, there was 3, pattern number 2, there was 2, and then 1 here. So we know we're going to have 4 of these grey ones. And then each of the patterns has a blank one either side. And then it just repeats however many greys we've got. So we've got 1, 2, 3, 4. A really bad diagram, but I'm sure you can do much better than me. And that would be my pattern number 4. It then says work out the total number of squares needed to make pattern number 7. Well, this should be okay, because we'd know there'd be 7 grey ones along the bottom with a white one either side. So they'll be all grey, and we know there's going to be 7 of those. And then it's just repeated on top here. So we'd have 7 more. But it says how many, work out the total number of squares. So if we've got 7 and 7 grey ones, that's 14 grey. Well, then we've got 1, 2 white ones as well. So 2 white, 14 grey, that's 16 squares altogether. So that wasn't too bad. AXA says that the total number of squares needed to make pattern number 20 is double the number of squares needed to make pattern number 10. Well, let's look at pattern 10. We know we're going to have 10 grey on the bottom, and then 10 more grey ones on top, and then 1, 2 either side. So that's going to be 20, and these 2 will be 22. And for pattern number 20, well, we're going to have 20 grey ones along the bottom, 20 resting on top of those, and then don't forget these ones either side, the 2 here. So that's going to make 40, and the 2 is 42. And then on your calculator, you can say, well, is 22 times 2 equal to 42? No, it isn't. So you can say, no, it is incorrect for AXA to say this. And you've got your explanations down here. Question 6. Jim says, if you add any two different prime numbers, the answer will never be a square number. And that's never will be a square number. So let's write the prime numbers down. 2, 3, 5, 7, not 9, but 11, 13, 17, 19, 23, and so on. Then can we add two of those numbers together that are prime, different ones, and if we get a square number, then we've shown that Jim is wrong. And I can see one staring out at me here, 2 and the 7. Well, that definitely makes 9. So 2 and 7 is 9, and that is 3 squared. So there's one counter example. So it's a counter example. Counter meaning against the belief that is stated in the beginning. So you're showing something which is counter to the initial argument. Okay? I can also see one here, and that is 13 and 3, which is 16, which is 4 squared, and I'm sure that you can probably find others as well. Can you see another one? Well, I'll change the colour here. 2 and the 23 is 25. Okay, so plenty of choices to choose from for that question. Question 7. Matthew has 8 cards. There is a number on each card. Work out the range of the numbers on the cards. Well, they range from the lowest being 1 right up to the highest being 8. So how does 1 and 8 differ? Well, you do the highest, take away the lowest, and 8 take away 1 is they range by 7. We then have to work out the median of the numbers on the cards. So we have to put them in size order. So I'll cross them off as I do them. Doesn't matter if we go from lowest to highest or highest to lowest. So 1, 2, 2, 3, 3, 6, 7, and don't forget that 8. And we've got to find the middle one. And if there isn't a middle one, then we have to look at the 2 in the middle. Okay, so if we look halfway, then we've got 4 going this way and 4 going that way. Now we've got to look what's in the middle here. Now we've got a 3 and a 3 either side, so common sense should tell us that the answer is going to be 3. But if you're not keen on that, just simply use your calculator and do the mean of those two numbers. So you do 3 and 3, which is 6, and then divide that answer that you get by 2. And you'd get 6 over 2, which is also 3. So I bet that tricks some people, but try not to let it trick you. Question 9. There are 19.5 litres of water in a container and a cup holds 210 millilitres, and we've got to work out how many cups can be completely filled using the water in the water container, and that's allowing for no spillage at all. So let's convert the 19.5 litres into millilitres, and you should know that there's 1,000 millilitres in 1 litre. So if we do 19.5 times 1,000 on the calculator, you'd get 19,500 millilitres. So what we've got to do is see how many of these divide into the 19,500. So I'm not going to try and make any mistakes here by doing by hand. This is a calculator exam, so let's use the calculator. So 19,500 divided by 210. That gives me 92.857142 recurring. Now it says how many cups can be completely filled, so we really should say 92 cups, because this decimal part is not a complete cup. Question 10. As I don't have a copy of the paper here, and if I did it would be a photocopy, then if I was to go through the entire question properly with a ruler, I wouldn't get the right answer anyway. But what to do is step 1, measure from A to B with a ruler, and then B to C. Make sure that you know the mark scheme allows plus or minus 2 millimeters accuracy, so you could have been over by 2 millimeters here, over by 2 millimeters here, don't forget. Then if you want to add these both up, and then all you have to do is times by 2, because for each centimetre you have, you've got to times it by 2, and then that's directly in kilometres. And so you'd write that figure down. And then if you just measure from A to C using your ruler, times by 2, and convert the centimetres into kilometres, then you should have a difference of, well, the mark scheme says 6 kilometres, so Tom walks more kilometres than Amy walks. How many more? Well, the answer's 6, but because of the inaccuracy, and don't forget you could have underestimated here, and then overestimated here, so there could be quite a big discrepancy between 4.8 and 7.2. But as long as you show all the measurements you got, then the mark scheme would be fine between 4.8 and 7.2 kilometres. Okay, so good luck with that question and see if you can get it within these bounds here. Question 11. It says there are 78 red counters and 52 yellow counters, and we've got to write the ratio of red to yellow in the simplest form. Well, you can use your calculator here, but I'm just going to halve both numbers. You can use your calculator or not. So if I halve this side, I must halve this side. And then I notice that 39 is 3 times 13, and 26 is 2 times 13. So I can divide both sides by 13, and I'll be left with the ratio 3 red to 2 yellow, and that would be in its simplest form. As it's a calculator exam, another way you can do this is if you divided both sides by 78, for example, this would be 1, and this would give you 2/3 on the calculator. Most of the calculators convert to fractions. And then you can times both sides by 3, and then you can get 3 to 2. Or you can start with 78 to 52, divide both sides by 52, and you'd get 3 over 2 to 1, and then times both sides by 2 to get rid of this denominator here, which would also give you 3 to 2. So there's plenty of ways of getting the correct answer. Question 12. Here is triangle ABC with each of its sides extended. Just means that they come off slightly from here. Okay. Now, show that triangle ABC is isosceles. Not an easy word to spell. It just means that two of the angles will be the same. Okay, that's all we've got to look out for. Now, let's look at this angle first. Well, it's opposite this one. So we can say that angle ABC is 46 degrees, and we can just put in there opposite angles. So we'll just mark that there. And then this angle here, and we'll call that angle CAB. Well, that's going to be, and you can use the calculator, that's going to be 67 degrees. And we can write down the reason, which hopefully you know, and that angle's on a straight line. When I use this symbol, by the way, it just stands for angle, because it's like an angle. It's a shorthand, which is perfectly allowable. So angles on a straight line. Add up to 180 degrees. So we'll put that one in, that's 67. Now, what we're hoping for is that this last angle here is either going to be 46 or 67. Now, I wouldn't worry too much, let's just carry on. So angle ACB is going to be 180 minus the 67 that we've already got, minus the 46. And we've got our calculator at hand, and I'm going to use it now. So we've got 180 minus 67 minus 46, and luckily for us that is 67 degrees. And we can put our reason there. Angles in a triangle add up to 180 degrees, and so we can use this sign here, which means therefore, that's how you spell it, F-O-R-E, therefore triangle ABC is isosceles because two angles are 67 degrees. So this one here is 67 degrees. So although it doesn't look like it's isosceles, they are 67. So it should say something here on the diagram, and I'm just going to check if it does. No, it usually says something like not drawn accurately here. I guess if it really was, you'd be able to measure them, and that's why some students just measure things and think that it looks the same. You've got to prove it. Okay, so in that situation we should know that this length here then will be the same as this length here, because if we turned the shape around, because they were 67 each, in real life the triangle would look more symmetrical, or more symmetric rather. So we'd have 67 here, this would be 67, and there'd be the lengths that were the same, and these base angles would be the same. Okay, so in the situation here I didn't use the word base angles because the triangle was in a different orientation. The 67s were not on a base, as in on the horizontal. Okay, so let's move on. Before I do, someone pointed out to me that I should have said vertically opposite angles. Question 13. It says 8 out of 10 of the people we teach pass the driving test first time. And then Ali talked to 56 people who had been taught to drive by the driving school. 43 of these people passed the test first time. So that would be 43 out of 56. And if we convert that to a decimal using our calculator, so 43 divided by 56, that gives us 0.76785 and so on, or roughly 76.8% to one decimal place. 8 out of 10, however, is 0.8 or exactly 80%. So you could argue, no, this does not support what is said in the advert. However, I think you would get awarded a mark for saying yes, because to one significant figure the percentages are the same. So I don't know if I particularly like this question, because I believe you'd get marks for saying no by showing the workings like so, and also get a mark for saying yes if you said to one significant figure they are indeed the same percentage. And the mark scheme does actually say the same about getting 1 mark for saying yes, as long as you can support it. Question 14. On the grid, we have to draw the graph of y equals 2x plus 1 from -2 to 3. So luckily our x-axis is labelled here from -2 to 3. So all we've got to do here is think carefully. Now, we should know that this is the gradient and this is the intercept. So what the intercept means is that when x is 0, so if I put x is 0 in here, I would have 2 lots of 0, which is 0, plus 1, and that would be our y value. So that means when x is 0, y is 1, and that's that coordinate there. Now we only actually need one other coordinate to draw this straight line. Now this is where the gradient comes into use, because what that means is for every one I go along here, I'd go up by twice as much, so I'd have to go up by 2, and I can draw another cross here on my graph. Okay, so I can go along another one and go up twice as much. Now from here I could have gone back 2 and down twice as much, which is 4. So 1, 2, 3, 4. Now I've got to graph this from -2 to 3, so I can just go along one more and up 2. Notice that this is going up by 1 here for each square, whereas this is going up by 1 for each 2 squares. And then I can just draw my line through these crosses. I don't have to have them all. Some people like to do an x and y table, like so, and then they'll start at -2, and then negative 1, 0, 1, 2 and 3. A nice thing is if you know that 0, 1 is a point here, i.e. the intercept, you know it's the 2 times table it goes up in, so you can just write 1, 3, 5, 7 and then back by 2, minus 1, minus 3 and plot those points. So negative 2, negative 3 is that point there. So I'll try and draw my line through here. I'm sure you'll do it a lot better than me. Let's do the colour here. Let's do another one. Let's have a look. Okay. So something along those lines there. Now we don't want this one here. So, and we can label it as well, y equals 2x plus 1. So there's plenty of opportunities there for you to have a look at drawing straight lines. There's plenty of ways of doing it. Question 15. The nth term of a number sequence is n squared plus 7. We've got to find the first 3 terms. So when n is 1, 2 and 3. Well, when n is 1, we'd have 1 squared plus 7, which is 1, and 7, which is 8. When n is 2, we'd have 2 squared plus 7, which is 4, and 7, which is 11. And for the third term, we'd have 3 squared plus 7. 3 squared is 9, plus 7 is 16. So 8, 11, and 16. It then says 128 is a term of this sequence. Which term? Well, if we put n squared plus 7 equal to 128, we've got an equation here. And if we take away 7 from both sides to start with, that will give us n squared is 121. And if we square root both sides, that will give us n is plus or minus 11. But we're not going to have a negative term here because we've started with the first, second and third terms as being positive integers, so we're going to have the number 11 for the term, and that's what we're going to write here, and that would give us 128. Question 16. I thought for this question it would be easier just to explain what I've done here. So I just copied the table out for 20 walnut biscuits and gave the ingredients here as was written in the table. And then what I did was I made 20 biscuits turn into 10 biscuits. And what I did was I divide all of the ingredients by 2. And of course use your calculator at any time. And you get these values here. And the nice thing about getting 10, the recipe for 10 is you can just times everything up by 5 to get to 50. So 25 times 5, 50 times 5, 20 times 5, 25 times 5 again. Notice we already had that. And then 1 times 5. And they should be the correct ingredients that you need. I thought it would be easier that way than you watching me write it all out by hand. Question 17. We've got to simplify y cubed, add another y cubed. Well, they both have to the power 3, and the bases, i.e. what's being given to the power 3, is both y. So we have one of them and another of them, which is going to be 2 of them. So for example, if we had x squared plus x, we could not simplify that because here the power is 1 and here the power is 2. So we could just leave it as x squared plus x. But if we had x squared plus x squared, they'd both be exactly the same base, i.e. x, and the powers would match, which means we could have one of them and another of them, which would give us 2x squared. Okay, so watch out for those types of questions. They can be a bit misleading, and if you're not sure, you'll just end up guessing and probably say something like y to the power 6, which would not be correct. Now we've got to factorise m squared plus m. Well, m squared is m times m plus m. So that's the m squared part here, and this is m here. Now, if we notice here, we have m in the first term of this expression, and we also have m here. Now, if I write this as m times m plus 1 times m, and if we circle the common factors, don't forget I could have circled this one, but I just have to circle one of them to show that it's a factor. Now, what we'd end up with is a common factor of m, and what would we have left? Well, we'd have to do m times this m here, plus m times 1 here. And if we multiply this out in a grid, and we had m plus 1 here, and m here, we'd have m squared and then 1m, which gives us m squared plus m. So this is the factorised form here, and this is what I would write in the answer. Now we have a formula C equals 3h plus 5. Now I've done quite a long video in a playlist, I think it's called Rearranging Equations, where I've done loads of these types of questions. So we want to make h the subject of the formula. So we're going to take away 5 from both sides, and that would give us c minus 5 equals 3h. Now 3h means 3 times h, so if we divide both sides by 3, that will give us c minus 5 all over 3 equals h. And that would be making h the subject of that formula. Question 18. Buses to Ashby leave every 24 minutes and buses to Barford leave every 20. A bus to Ashby and a bus to Barford both leave the bus station at 7:30 AM. When will a bus to Ashby and a bus to Barford next leave the bus station at the same time? Well, it's about looking at the lowest common multiple of 24 and 20. And what I do is I break it down into prime factors. So that's 24 broken down into 2, 2, 2 and 3, all under multiplication of course. This is 2 times 10, which is 2 times 5. And then I circle what factors they have in common. So they both have 2 here, and then another 2, which is 4 under multiplication. And then, oh dear, that was wrong. So that's it. So they have 4 as a common factor. And the nice thing about this is each number would like to get hold of the other factor. So if the 5 was gotten hold of by the 24, well, 5 times 24 is 120, then 24 would have all the factors that 20 had. But then 20 would like to get its hands on the 2 times the 3, which is 6. And if you do 2 times 3 times 20, well, on the calculator, you also get 120. So it's about seeing, and I'll put this in a different colour, it's about looking at the factors they don't have in common and then multiplying by the number that doesn't have that factor. So I'll give another quick example. Say you had 30 and 24. Well, this will be 2 times 15, which is 3 times 5. This is 2 times 12, which is 2 times 6, which is 2 times 3. Circle what they do have in common. So I'm not going to mess this up this time. And then you can see that, and I'll change the colour. So you can see that 5 is needed by the 24. So 5 times 24 is 120. And you can see here that the 4 is needed by the 30, and 4 30s are also 120. So as it happened, the lowest common multiple of 30 and 24 is the same as the lowest common multiple of 24 and 20. So let's go back to the question. If we know that the lowest common multiple of 24 and 20 is 120, then that's 120 minutes, don't forget, which is 2 hours. So that would be the next time that they both left the bus station at the same time. So if we add 2 hours to 7:30 a.m, we get 9:30 a.m. Question 19. Amzal thinks that x plus 5 all squared is x squared plus 25. But if we times x plus 5 by itself, then yes, we do get x squared, so that seems to be correct. If we times the 5 by the 5, yeah, we'll get 25. But I think Amzal's missed something here, because if we do x times 5, we don't get x5, we get 5x. And if we do 5 times x, we get 5x. So he's actually missed out 10x here, because x plus 5 all squared is x squared plus the 5x plus another 5x plus 25, which is actually x squared plus 10x plus 25. So be careful. A lot of students do think that a plus b all squared is a squared plus b squared. But if you think about something, if you just put some numbers in here, 2 plus 3 for example, squared, what is that 2 squared plus 3 squared? Well, 2 plus 3 is 5, and 5 squared is 25, but 4 plus 9 is 13, and 13 is not equal to 25. So that's not how we square things, okay? So it's a common misconception. So I guess we should say on here as well, Amzal is incorrect, to make sure we don't lose any marks. Question 20. Kim, Laura and Molly share £385. The ratio of money Kim gets to the amount of money Molly gets is 2 to 5. So here's one method that a student of mine did. They said that Kim had 2 parts, Laura had X parts, and Molly had 5. And all these parts added up to 2 and 5, which is 7 plus X. So we had 7 plus X parts, and we have to divide that 385 divided by those parts, and that would be 1 part. Now we know that Kim got 2 parts, so she had 2 lots of 385 over 7 plus X. And Molly, well, she had 5 of those parts, so I'll write that the same way. But Kim gets £105 less than what Molly had. So they came up with this really nice equation, which I thought was really good. And if we multiply this out, we get 770 over 7 plus X equals, and you've got a calculator here, 1925 over 7 plus X minus 105. Then you could take this from both sides, and that would give you 1925 minus 770 over 7 plus X. Add this 105 to both sides. Then you can multiply up by the 7 plus X, and that would give you 735 plus 105x equals the difference between these two numbers, and that is 1925 minus 770, which is 1155. And then we can take 735 from both sides and divide by 105. So x is 4. So what they did next was to say that the ratio for Laura's part was 4. So they knew then that there were 2 and 4, which is 6 and 5. There were 11 parts altogether. So on the calculator they did 385 divided by 11, and that gave £35 per part. They then did 4 times 35 because Laura had 4 parts, and that's 140. And then they did 140 out of 385 to work out the percentage, which is 36.36% recurring. So I thought that was a really great way of doing the question. There are some easier ways of doing the question, and I will give you perhaps one easier way of doing it. And we'd start off by saying Kim to Molly was 2 to 5, and Molly had 3 parts more. Now that's interesting because those 3 parts had to be worth that £105 difference. So one part would then be, and use your calculator, you do 105 divided by 3, which is £35 per part. And then you can say that Kim would have had 2 of those, which would be 70, and then Molly, she had 5 of those, and 5 times 35 is 200. Let's have a look. Do that on my calculator. 35 times 5, that's 175, and then altogether they add up to 245, which would leave Laura with the difference from 245 to 385. So if I do 385, take away 245, that gives 140 pounds, and then you just do 140 out of 385 again as a percentage and get 36.36%. These double dots here mean just the 36, 36, 36, it keeps recurring. So to one decimal place, 36.4%. So I'm sorry if I had to put you through that part here, but I just wanted to show you there's many lovely ways of attempting the same questions. There's some nice quick ways and some slow ways, but quite ingenious. Okay, so good luck with finding your own ways through these types of question. Question 21. The table shows some information about the heights of 60 trees, and Jacob drew this frequency polygon, and we had to outline 2 things that were not correct. Well, I've outlined them here. I've said the midpoints were not used. Okay, so you can check back to the original frequency diagram table, and you can see here between 0 and 4 we should have gone 2 and then up 13, which was not done. It went from 4 to 13 and so on. And then the other part, when you use a frequency polygon, think of a polygon as just having straight edges or line segments, and this one clearly doesn't, it's curved. So there's my explanations. The midpoints were not used and the line segments were not drawn, i.e. it was curvy. Question 22. Quite a tough question, I think, for a lot of people. It says the price of all rail tickets did increase by 5%. So let's just have a picture of a ticket there, and we want to increase it by 5%. Well, if we times it by 0.5, then we'd be finding 50% of that ticket. Okay, now we've got to have a £2.30 increase. So some ticket times by 0.5 would give us a 50% increase. So we don't want to times it by 0.5. If we times it by 0.2, that would be a 20% increase, because I could just write a 0 here and that would help me remind me of the fact that it was a 20% increase. So if I was to times it by, let's just work this out. So if I was to times it by 0.09, what percentage increase do you think that would be? Well, it would be a 9% increase. So we need to times it by 0.5, and that would be a 5% increase. And so for argument's sake, we've got our ticket here. We've times by 0.05, which is a 5% increase, and we've ended up with this. So if I write this out, and I'll call the ticket, I'll just call it T. So T times 0.05 equals 2.30. Now, if we want to isolate T here, all we've got to do is divide both sides by 0.05 because the operation was multiplication here. Do the same to both sides because it was a balance, indicated by this sign here, equal sign. And we would therefore have T is equal to 2.30 divided by 0.05, and our calculator comes to the rescue. So 2.30, you don't need to write the 0, divided by 0.05, and that would be £46. So only £46, 5% of that would be £2.30. So you can verify that if you have time to check in the exam, because if you found 10% of 46, it would be £4.60, and 5% would be £2.30. So you could have checked your answer that way. Question 23. We're shown a regular pentagon, and BCF and EDF are straight lines, and we've got to work out the size of angle CFD, which is this angle here. Okay, just so in case you're stuck, CFD. Now we've got to show how to get the answer. I'm not going to write brilliant sentences down here. You're going to have to do those yourself and get practiced at doing those. I'm just going to try and show you how to get to the size of the angle. Well, first things first, I would set about it doing this way. And I know when I've done these kind of problems before, people have commented saying, well, I can do it better or faster. Then brilliant, that's good. I can only do it the way I would do it. So first of all, I would split that into 5. I wouldn't necessarily draw all 5 parts, but I would then take my calculator and do 360 divided by 5, and that would be 72 degrees for these parts here. So all of those are 72. Okay, I just drew a few of them there for you. I then know that because it's a regular pentagon, that these are isosceles triangles, and the angles in a triangle add up to 180, so that would leave 108 for this one and this one combined, and as it's isosceles they would be the same, so I'd split 108 into 2 parts on my calculator, and that would make those 54 each. Now, if that's 54 degrees here, because this isosceles triangle and this one, they're all the same, then I know that this one's 54. Now 54 and 54 is 108, which leaves 72 here. Now there's a definite pattern with all the regular polygons, and that this centre angle is the same as this external one here. So if I had an equilateral triangle and I just moved one of these lines and made it extend, then because this was 60 here, I know that if I had the centre angle here, each one of those would be 120 because they'd have to go round to form a whole turn. And can you see that this 120 here is a centre angle, and this is 120 as well. It's always the case, the centre angle and the external angle are always going to be the same. But if you don't know that, you can just work it out how I did and just start from the beginning and just use common sense. So we know then that as this is a regular pentagon, then EDF BDF and BCF must have the same length because they both come off a similar side, which is regular in that pentagon. So this one's not shorter than this one, so they are going to meet at a point, and these two parts are going to be equal, which means that this is an isosceles triangle as well. So this base angle is 72, and you could work that out by doing the same thing here, using a line of symmetry through here, okay? Now, if that's 72 and that's 72, that would make 144 degrees, and then angles in this triangle would add up to 180 as well, and that would make this angle here, the one we wanted, 36 degrees for that reason. Now if I change colour here, some of you could probably be inventive and say, well, hold on, there's a triangle here, and I know this angle, I know that one because it's half of the 72, which is 36, and I know this one, it's 54 for the same reason that this one was, and so the angles in a triangle make 180, and if I've got 54 and 72 and 36, then what are those added up? Well, let's add them up. So I get 54 and 72 and 36. That would give me 162, which would mean that this angle here is 18, and then by symmetry this angle would be 18 as well, which would also give us the desired outcome of 36 degrees. Okay, so I'll write a few comments down, but I'm not going to do those live, I'm just going to do them and then you'll just see them at the end of the video. So I've said things like the angle at the centre of the pentagon is 72 because 360 divided by 5 is 72, and that's about a whole turn divided by the number of sides, which was 5. I then went on to say the pentagon was split into 5 isosceles triangles with base angles 54 degrees. You might want to add in the word regular, which means all those isosceles triangles are congruent, exactly the same. And you can say that the base angles in those isosceles triangles are 54, and that the angles were found because angles in a triangle add up to 180. Then we looked at this line here, BCF, and we know angles on a straight line are 180 degrees, and we then said CDF was isosceles, but remember you could have then said you could have used this, called this X, the centre here, and you could have gone off on your own way and said, well, BXF is a triangle and I know 2 of the angles from that using symmetry. So there's plenty of ways of addressing it. Just try and attempt to write things in some kind of good progression using words like isosceles, regular, talk about the pentagon because that's in the question, and things like angles on a straight line or angles around a point in a whole turn, for example. Try and get those things down. Takes a long time, but it is worth it. Question 24. It says a garden is in the shape of a rectangle and a semicircle, as shown in the diagram. And it says AD is the diameter of the semicircle. We know that a box of fertiliser is $4.99 for each box, and we know that that will cover 12 metre squares of garden. So I think we should work out the total metre square area of the garden, I believe. So let's do the rectangle first. So I'm definitely going to use the calculator for this, and we're going to have 8.4 times 5.6. So we'll do area of rectangle, and that's going to be 8.4 times 5.6, which gives 47.04 metre squares. And then we've got the area of the semicircular part. Now we know the area of a circle is pi times the radius squared. Now, if we were looking at the whole circle here, we'd have pi times, well, the radius would be half of this diameter, which is 8.4. So that would be 4.2 squared. And that would be the area of the whole circle, but we only want the semicircle. So we're going to divide that by 2, and that will be the area of the semicircle. And we can work that out on the calculator. So you find your pi button, which always is difficult for me to find. There it is. So pi times 4.2 squared. So I'm going to write that down first, the top part, and that's 55.41769,441, and then that's divided by 2, just so I don't make any errors here, and that's going to be 27.7088472 metre squares. So what I now can do is work out the total area. So total area is going to be this one and this one. So I'm going to add those together, and I get 74.74888472 metre squares. Now we know that every 12 metre square that we can fit into this number will cost us £4.99 of fertiliser. So I believe that if we do 74.74888472 divided by 12, so my calculator gives 6.22900706, and that's how many times we can get 12 into that number. Then I think we have to be a bit careful, because if I just enlarge this, if we thought we needed just 6 bags of fertiliser, then the 0.22900706 times that's left over would mean that there was area left over that wasn't treated with fertiliser. So to be sure that you had enough, I'm afraid you'd have to get an extra bag. You're not going to be able to go to the shop and just take a few scoops out of the bag. You're going to have to buy a whole new one. So you're going to need 7 bags at £4.99, and £4.99 times 7, that is £34.93. Okay, so that's the answer for the first part. The second part, let's have a look. Carol finds out that 1 box of fertiliser will cover more than 12 metre squares of garden. Explain how this might affect the number of boxes she needs to buy. Well, I think this is quite an easy question to get wrong, I have to say, although it's 1 mark. You might jump to the conclusion and think she'll need to definitely buy less boxes. Well, that's not necessarily true, because if you worked out that, for example, it covered 12.1 metre squares for each bag, then you'd be dividing this number here. Let me just show you what I'm talking about. You'd be dividing this number here, the total area, by something bigger than 12. So let's say 12.1. So if I do that same calculation but divide by 12.1 instead, I'll get 74.74888472 divided by 12.1, and that gives me 6.1775, and so on. So you'd still need to buy 7, even though it covered slightly more. So it's quite tricky, but there'll be a certain cut-off point where this number will be exactly 6, but this will be 12 point something, I believe. Let's try 13 and see. I should know that. 6 13s are 78, so you're never going to get to 13. So it's going to be 12 point something. So I think the easiest way of looking at this is to say she may need to buy less boxes. Okay, so I think my answer would be she may, not definitely, she may need to buy less boxes. So probably one of the most difficult questions on the paper. Yeah, so that's my answer anyway. Question 25. Samina has a round pencil case and a square pencil case, and there are 4 blue pens and 3 red pens in the round one, and 3 blue and 5 red in the square one. So Samina takes at random 1 pen out of each pencil case. We've got to complete the probability tree diagram. So to pick a blue pen out of the round pencil case, we've got to be looking at a total of 7. And how many blues are there? Well, there are 4. So that would mean that we had the 3 red. Now we've got to see what happens with the square pencil case once we have chosen, say, this option first. Well, if we look in the square pencil case, there are a total of 8 pens altogether. And there are still going to be 3 blue pens left in it, because the one that went before was taking a blue out of the round pencil case, which is not the square pencil case. Now let's have a look at the next part of the tree. Well, there's still going to be 8 in here, and how many reds are there? Well, we've got 5 here, so that's going to be 5 out of 8. If we're taking a red out of the round pencil case, then we'd have to consider the square pencil case situation, and we would still have 8 pencils in the case, and picking a red one out of the round pencil case would have no effect on the square pencil case. So in terms of blue, well, in that term there's going to still be 3 here, and then 5 for the red. Now I think some people might have got confused because they might think that the blue one from here means there's going to be 1 less blue one from here, but it's the type of pencil case that is changing here. It's not the same pencil case in each case. Now we've got to work out the probability that the pens Samina takes are both red. Well, both red would be this one option here. So let's work out the probability of getting to here from here, where we'd have 3/7. That's the probability of getting to here, i.e. choosing red from the round pencil case, and then 5/8 of this probability here of choosing red from the round pencil case and then a red from the square pencil case. Okay, so that's 15 out of 56. And don't forget, you can use your calculator if that speeds things up a bit. Question 26. We have to write 340 million in standard form. So standard form is all about powers of 10. So we want to see how many powers of 10 we can have in this number. But we have to start with a number between 1 and 10. So the number we can see is 3.4, coming from the first 2 digits. And what we must ask ourselves is, how many times would we have to times 3.4 by 10 to get 340 million? Well, there's a nice way of looking at this. If I write the number out again, if we start from, say, 3.4, then we'd have to times by 10 once, twice, 3 times, 4 times, 5, 6, 7, 8 times. Now, if I keyed in this in my calculator, 3.4 times 10 to the power of 8, then it does actually give this number here, which is an ordinary number. I'll write that down, ordinary number. But this is therefore the standard form, so I've definitely checked it out, and my calculator does definitely tell me that that's the answer. So that's part A. Now part B, work out 1.67 times 10 to the minus 7, all divided by 9.11 times 10 to the minus 3. Well, I can write that as a fraction, and then the denominator. And then what I suggest you do is, if you're not really sure of what you're doing, then just do the top part first. So you can do 1.67 times 10 to the power negative, you have a negative key sometimes on the calculator, that looks like that, negative 7. Now, if you were lucky enough to have a calculator that would give you that as a decimal, you're fine. Mine actually doesn't. So really, I've only got one option here, and I can't really write it out as a decimal at the top and then divide by the decimal at the bottom in 2 stages. I think what I would have to do in this circumstance is this. So we'll go back to the beginning. I'm just going to key in bracket and then 1.67 times 10 to the power negative 7. So, and then I'm going to close the bracket, and then I'm going to press the divide key and then open the bracket again, and then type in 9.11 times 10 to the power negative 3, and then close the bracket. So open bracket, type this in, close bracket, and then divide, open bracket, write this in, close bracket, and then press equals, and I get 1.833150384 times 10 to the minus 5. Now we've got to give the answer to 3 significant figures. So let's have a look closely at the number. So first, second, third significant figure, and if we look here, this is a 3, which is going to have no effect on this number. It would have to have been a 5, a 6, a 7, an 8 or a 9 to round it up, so it has no effect. So in standard form we'd have 1.83 times 10 to the minus 5 to 3 SF, significant figures, but we've got to write it as an ordinary number, which can be easily overlooked, so please read the questions carefully. I'll let you into a little secret. I missed that part off and had to rewind and do it again, so anyone can make that mistake. So let's follow the instruction here, 10 to the minus 5, which means, well, if you had 10 to the 5, it would mean timesing by 10 5 times. So in this case, we want to divide by 10 5 times. That's all that means. So we take the number 1.83 and we divide it by 10 1, 2, 3, 4, 5 times. And we'd be left with 0.0000183 to 3 significant figures, because that would be as an ordinary number. This is the standard form. number. Question 27. It says ABC is a right-angled triangle, and we've got to work out the size of the angle marked X. Well, we've got to give that to one decimal place. So if you know the basics of trigonometry, then you've heard of this before, SOHCAHTOA. To really understand trigonometry, you'd have to understand the unit circle and where it came from, where sines and cosines came from. I'm not going to do that in this video, but I have got videos on the unit circle, as have lots of other people on YouTube, so I would definitely look at those first before going into the real understandings of the question. Now, in this situation, if you look at the angle, the opposite side is 1.9 and the adjacent side is 3.2, and obviously the side opposite the right angle, always the longest side, would be the hypotenuse. So in this situation we have opposite and the adjacent, so we've got the tan. So we've got tan of X is opposite over adjacent, and I'll do that on my calculator. So we've got 1.9 divided by 3.2. You don't have to decimalize this, I can show you a quicker way, but we get 0.59375. So that's what tan of X is. But we want to find X. So mathematically, what we're really doing is we're finding the inverse of tan to find the actual angle. So what we're actually doing to both sides, let's just get this bit right here, put a 5 in here, which wasn't there. We're going to tan minus 1 of both sides, and if we do the inverse tan of tan, we're just left with the angle. So what we put in our calculator is tan to the minus 1, or arctan, it's known as arctan, of 0.59375, and the calculator display would say 30.699,72255, and we want that to one decimal place, so we're going to get 30.7 degrees, and I'm going to write 1 dp in there. The quicker way of doing it was to take this here and just do bracket 1.9 divided by 3.2, and in front of that we would just do tan minus 1 of that bracket. Okay, so we could do it all in one go, so we can do shift tan 1.9 divided by 3.2, close bracket, because my calculator opens a bracket up straight away, yours might not, and if I press enter I get exactly the same decimal here. So 30.7 degrees to one decimal place.